Okay, so we have Unit 2, Lesson 3. So this one today is more about factoring patterns. Okay, so understanding that it can be factored, your same rules apply if it holds the same pattern. And I'll show you what I mean by pattern when we get to exponents. We're going to be able to factor things that have a 6 or a 4 if the middle term is half of that. Okay, it's kind of the main idea. So let's just kind of talk about it. So in previous lessons, we factored by inspection the x squared stuff without a number in front. So this one was our inspection method. So there was nothing in front of the x squared. That was kind of the easier ones. Last class, we did decomp for when we have a number in front, where we times the a and the c to get started. Okay. In this lesson, we're going to extend the process and consider expressions with variables can be replaced with the function x. So, this is kind of what it's talking about here. So we can still use inspection today. We can still use decomp. It just depends what's left when we simplify or we kind of group. And it's kind of weird. I'm kind of struggling to find the right word to explain it, but maybe as we go, you'll get it. Okay, so anyways, we're used to doing inspection with 2, 1, 0. What that means is exponent 0, 2, 1, and 0. Okay? And there's an x to the 0 power there, if you will. What is x? What's anything to the 0 power? Do you guys remember that rule? No, it's 1. It's a common mistake. People think 0 sometimes. Okay? Anything to the 0 power is 1. Okay? So what I'm telling you is that this follows 2, 1. It's a bad spot there. This follows 2, 1, 0 principles. That's what we've been doing. Okay? So far we've been doing the x squared, x1, x0. But the idea is the method of inspection also be used if we had a 4, 2, or 0, or a 6, 3, or 0. So do you see the pattern? The pattern is the first exponent is twice as big as the second one. So what it's saying is that if I wanted you guys to factor, we'll just kind of do one here. Let's do an easy one here. Not that. I wanted to do 3. So I could factor that by inspection. Now, when you first look at that, and I guarantee this is going to happen to you, you're going to be, whoa, 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 x6. That is not going to be fun. But all you have to do is say, wait a second, 6, 3, 0. It follows the 2, 1, 0 pattern. Right? So, what would this factor to? Just see if you guys can stand with me here. What are factors of 3 that add up to 4? I gave you the easy one. 3 times 1, the only one possible, correct? So the only thing now you have to kind of maybe scratch your head about is, what goes here? Well, what gives you an x6? What gives? Close. x3. Yeah, x3 and x3. Remember, exponents, you add them. x3 times x3 is x6. When you're multiplying exponents, you add them, correct? So we just did that problem. So that's over. We factored it. Okay, so that's kind of the idea today. I kind of jumped the gun. We're going to do some more of those, but I kind of like to, as I'm delivering the information, give you a quick little run through. Any questions on that? Okay, so let's see here. Let's look at this following example here. So x4, x2, and 0. 4, 2, 0 follows the pattern. Okay, and this is how they like to explain it. They like to explain it, well, it's still the same idea from before. I don't like doing the grouping they do because I just think it makes it more confusing, but they're just showing you that if I colored this here, something squared, something 5, and a 6 would factor to that's something plus 3, that's something plus 2. Well, what is the thing inside the parentheses, though? What's being squared? The x squared. So they're just saying that's what would go here. That's kind of how they describe it in terms of they simplify it. So the way I wrote mine, here, stay with me. This would be x cubed squared plus 4 x, and then it would be, so we want to go 2, so it would just be 4x 3, and then it would be plus 6. So you see the thing in parentheses is the x3, so that goes here, and then we just factor it like normal. That's kind of how the book explains it. You don't have to do that every time if you don't want. That's how they're showing you that it's still the same form. It's regular x squared form that we started with in the very beginning. Okay, it still comes back to that. Okay, and that's all they're talking about here. Make substitution, put the x squared in for a. Okay, so you guys kind of get the idea with that, hopefully. But let's go ahead and get to this here. So factor completely. Okay, so for this one, again, you don't have to do the parentheses way. That's fine. If you recognize I have 4, 2, 0, I can factor this. Okay, what I do personally, who can tell me when you're factoring, and we did this last class by having x, y as the middle, what is the thing, what variable or what term is always going to lead you off in the front? What variable or term is always going to lead you off in the front? What I mean by that is, if I'm factoring this down, it's going to be a to the something, okay, and we know it's going to be, that's a negative, it's going to be plus, minus. How do I know what a this is? A1, A2, A3. Where can you look every time and know? The middle. Whatever the middle is, a squared, these have to be. Yeah? Do you see that? A squared times a squared is A4. Okay? All right, factors of 14, the difference of 5. Should have 7 and 2. Since it's a negative 5, I want a negative 7. There you go. And you're done. Is there a difference of square up there? No. There could be. I got to check. But there isn't on this one. Okay. All right, this one here. 4, 2, 0. So we're good. Okay, so again, the middle is x squared, so I know I'm having x squared in front. It's a negative 5, so I'm going to have a plus, I'm going to have a minus. It's going to be positive 5, negative 1. 5 minus 1 is 4. That one's done. Okay, just for a second here. I'm just going to show you one more time how they're doing it with substitution. Okay, so what is the a? The a is x squared. That's the substitution. All right, and last one, 6, 3, 0 meets our criteria because this is twice as big as the middle. Again, that is what we're going to lead off with. So we have x3 to start. x3 to start. I have a plus this time, and it's a negative 9, so it's going to be minus minus. Because negative times a negative is a positive. Negative plus a negative is a bigger negative. And factors of 14 that add up to 9 is 7 and 2. Again, no perfect squares there, so I'm good. All right. Any questions? It's going smoothly so far, we sure? All right. All right. Factoring trinomials of the form. Just what we've been talking about. A is the f of x squared plus b is the f of x plus c. F of x is kind of like what you're throwing in there. And so I think the best way to explain it is just that they're trying to make you substitute here. So let's just kind of just get to the examples for it here. Again, we still don't have to substitute because in my mind, I just know that this is going to be x2 is what I'm dealing with in the middle. Now, when I do these ones here, what do you notice about what's wrong with A right now that might be throwing you off or you may be worried about? 4. Yeah, the 4, right? So first thing I'm going to do is check if I can GCF. We can't GCF because 4 doesn't go into 5 or 6. So then what do we have to do? We have to do decomp. So I have to go 4 times negative 6 is a negative 24. What factors of 24 are 5 apart? What we got? 8 and 3. That's a negative, so I want a negative 8 and a positive 3. Okay, now we bust them up. Now the key is this is the middle, so these are x squareds. So I'm going to 4x4 minus 8x squared plus 3x squared minus 6, and then I'm going to group. Everybody still good? Okay, so what can I take out of here, Kyle? 4x squared, right? So that gives me x squared minus 2. Okay, Sarah, what can I take out the second one? 3, right? So I'm going to take 3 out. That gives me x squared minus 2. We feel good because those match. We push these two together. So your answer is right there. So really, you're not really learning anything new. You're just saying, okay, I know what to do if it's still in the same pattern. That's the only thing you really learned today. If it's still in the 2, 1, 0 pattern, you're good to go. Okay, so B, we have 2 variables. I have 2a squared, 2b squared, an ab in the middle, and then a number. Is this follow 2, 1, 0? Yeah, it does. It still has 2 here, 1 here, and 0 here for both of them. So A and B is kind of like a package deal. Okay, your AB is your package deal. So now, can I GCF? I can't. Okay, so I have to go 2 times 99. 2 times 99 is 198. I got to break 198 down to 2 negatives to add to 31. 9 and 22, good. 9, 22. Okay, so I'm going to put the 22 with the 2 and the 9 with the 99. So here we go. So we got 2a squared, b squared, minus 22 what? What do I put there? ab, good. Everybody's on board. Okay, minus 9ab, shoot, ran out of room. And plus 99. Okay, then let's group. Okay, Adam, what comes out of the first one? 2 and, yeah, AB. Good. So that gives me 2AB times AB minus 11. Okay, and Zach, what comes out of the second one? Yeah. Good. Now, this is kind of what we're talking about in our warm-up. See how this one's a negative one? I'm going to take out a negative in this case. Okay? That's when I'd like to do it. AB minus 11. Oops, one too many dashes there. All right, so again, they match, so we feel good about it. Push the 2AB minus 9 together, and we're done. 2AB minus 9. AB minus 11. Okay? All right. Got one more and then one more page. All right. Factor this one completely. Okay, so I'm going to give you a second to try this on your own. You're going to have to use decomp. Okay, so try this on your own, see how you do. I'll give you about 2 minutes, and then I'll continue and I'll go ahead and go. Okay, Ty, how do you want to start this one? Okay, good. So negative 24. Okay, good. So you broke down to negative 2x squared and 12x squared. So we're going to put that here in the middle so we can go by grouping. I'll probably write it just the way I have it here. So, like this. And now we're grouping. Okay. Okay, 2x squared out. Yep. Gives me 4x squared minus 1. Yep, so you take a 3 out. Gives you 4x squared minus 1. So we have 2x squared plus 3 gets pushed together. 4x squared minus 1. Okay, are we done? Ooh, no. Why not, Emma? Yep, good. See somebody catch it. All right, here's the difference of squares. 4 is perfect square, 1 is perfect square. So we can break that one down one more time. So this breaks down to 2x plus 1, 2x minus 1, and then we have the 2x squared plus 3. So you have 3 groups on this one. Very nice, very nice. Okay. First one, 2. Yeah. Okay. All right. Okay. So there's 2 more examples, and I'll let you guys practice. Okay. So this right here, they're really trying to make you use. Substitution. That's why they're putting the sines and cosines in here now. But we still don't have to. Okay. Okay. So like what I would tell you is that a square? Yeah. Is that just to the 1? Yeah. Is that a 0? So it's still 2, 1, 0. So the sine x, treat the sine x when you see this as just your x, if that makes sense. Okay? Just treat it as your x. So we're still going to factor like normal. I can't GCF here, so I'm going to go 6 times 2. I'm still going to get 12. I need multiples of 12 that add up to negative 7, negative 4, and negative 3. Okay? And so what is my middle term? Connor, what's my middle term? Right, so my middle term is sine x, so you're putting sine x on these, okay? So I'm going to go 6 sine squared x minus 3 sine x minus 4 sine x plus 2. And I know this looks disgusting and not very nice, but just trust your patterns, okay? This is nothing new mathematically other than writing the word sine, okay? You know, sines for trigonometry, hopefully you remember that, okay? So group. What do these have in common? A 3 sine x. That makes 2. 6 divided by 3 is 2. I took one of the signs off the 2 of them, so it's still a sine x in there. I took all that out. So if you took that whole thing out, what's left? Just a 1. So 2 sine x minus 1 there. Over here, I'm going to take out a negative 2. That gives me 2 sine x minus 1. So you can see, again, we're happy because these match. So we can push the other ones together. Right here? Why do I have this? Because there was 2 sine x's, and now there's 1. This reads as like a sine, that's like a 1. That's, again, picture this. There's 2 sine. Like, the sine, this means right here, okay, I see what you're saying. In trigonometry, when you're writing this, does that make sense? They write it like this. And so it does mean the group squared. Okay? Yep. Okay, so what her hang up was, if you're just kind of catching up, is that she's like the sine squared, not the x. Well, in trigonometry, that's just how they write it when it's actually the whole thing. Okay, good. And to finish off here, probably won't write with yellow much longer here. Okay, and that's good. Make sure we're good. 2 sine x minus 1, 3 sine x minus 2. Good. All right. One more of these ugly ones here. All right, what factors of negative 12 can break mine down there? Davin, what do you think? Factors of negative 12 that'll give me 11. So factors of 12 that are 11 apart. 12 and 1, yeah, sure question. Since 11's positive, the 12's positive. So we're 12, negative 1. Okay? So again, what's my middle? It's cosine x. So these have a cosine x on them. So I'm going to go 4 cosine squared x minus 12 cosine x. Oops, plus, sorry. Minus 1. I don't have to write a 1, but I will just so that you see it. Cosine x minus 3. Now we'll group. Okay. What do these have in common? 4 cosine x. 4 cosine x comes out. Cosine x plus 3 is in. Okay, what about this one? Just a negative 1. Okay, and now we can push these match. We feel good. 4 cosine x minus 1 times cosine x plus 3. Okay, again, I know those are ugly, a lot of writing. Okay, they don't look nice, but I really feel like those are probably just as easy as the last ones. Okay, we have one more set here. Okay, the next set, I will tell you, the test generator likes to use ones like these, so I would pay attention to this next couple, for sure. Huh? Okay, so, again, they're really forcing us to use substitution, which we can. Okay, and probably in this case, it's probably easier to substitution. What I would do if I was you, if you see this right here, because a lot of people get really confused, like what I have a lot of people do, like they'll like combine the 4 minus 10 and combine like terms, and then they're just all messed up. Because right now we want to factor it, right? So write it like this. 7 times a squared minus 4 times a minus 3. And just know your a is x minus 3. Just know that your a is x minus 3. And let's just factor it and then put the stuff back in for a. So do I have a GCF here? No, I don't. So I have to do my decomp. So negative 21 is what we're dealing with. Okay, what do you think, Spencer? Factors of negative 21 that are 4 apart. That are 4 apart. So 2 things that multiply to get 21 that are 4 apart. Like what numbers multiply to get 21? Okay, good. Negative 7 and 3. Okay, so I'm going to insert those in and just put an a on them. Don't put the x minus 3 yet, just put an a on them. So I'm going to go 7a squared minus 7a plus 3a minus 3. Are we okay with the substitution, what I've done so far, where the a's are coming from? Yeah? Okay, so now let's go ahead and group. 7a they have in common. So that's going to make that actually just be a minus 1. They have a 3 in common. A minus 1. We feel good because I got a minus 1. They still matched up. Okay, so I come down here. I have 7a plus 3, and then I have a minus 1 is my factored answer. At this point, we insert x minus 3 back in. So I'll put that right here and right here. So this is what it's going to look like. 7 times x minus 3, because that's what 7a is, plus 3. So if we work that out, what's 7 times x? 7x. 7 times negative 3 is negative 21 plus 3, negative 18. That's what that simplifies down to all the way. Okay, then we have a minus 1. So this one is going to be x minus 3 minus 1. So what's that leave us with? X minus 4. And that one's done. Yep. For B? 1? You mean like the number? Yeah. It's a 1. So you'll still have we're still going to do the same thing. I'm going to make those an A, and the middle term on part B will be a 1A. Because if there's nothing in front, we assume it's a 1, right? Yeah. Okay, yep. So here we go. So A on this one's going to be A plus 4. 9A squared plus A minus 10. I can't GCF, so I still have to do my decomp. Okay. Liam, what do you think? Negative 90, 1 apart. Nine, 10, yeah, the one we did, right? 9, 10, with which one being positive? Good. Okay, so I'm going to go 9a squared minus 9a plus 10a minus 10. Again, these inserted right here. There are the middle terms split up. Okay, if you're still trying to figure out decomp, or you're still trying to figure out that factoring method, all we're doing, again, what's negative 9 plus 10? It's 1. We're just busting this up into 2 so we can do grouping. That's all we're doing. Okay, so take this out. 9a comes out here. I get a minus 1 again. I take a 10 out here. A minus 1. So our answer before we insert is that for factoring. Okay, so let's insert in the a plus 4 now. So if I go 9 times a plus 4, gives me 9a plus 36. 36 plus 10 is 46. So 9a plus 46 on that one. Sorry, I can write the plus 10 here. Okay, my second part of the answer, a minus 1, so that's going to be a plus 4 minus 1. 4 minus 1 is 3. And there's that one. Whew.